start the Shabab in today's class. Today, inshallah, we will continue discussions about the speed control. We discussed previously the different types of speed control. We have only one technique we did not discuss yet, which is slip energy recovery. However, all other techniques have been discussed. And the topics today, inshallah, is to discuss the slip energy recovery and solve some problems regarding speed control as well. So, last class, Shabab, we stopped at examples. Here, we solved an example and we asked you to prepare this one. Here, in this example, for the motor described in example number 3, so let's have a look to the nameplate data in example number 3. It's a 480 volt, 2-pole, 60 Hertz start induction motor, has inductive reactance 4 ohms, stator resistance 0.2 ohms, and 0.3 ohms rotor resistance. The load torque is 60 Newton meter, which is constant load torque, and the speed at full load is 3500 RPM. So this is the nameplate data or all of data given for this motor. Now, we need to compute the motor speed if the current, compute the motor speed and starting current if the frequency is decreased to 50 Hertz. Did we solve this example, Shabab?
No.
We did not. Okay. Right. So now, Shabab, if the frequency is decreased, what will happen? We have many parameters. As we discussed before, if we have the motor characteristic like that, assume this is a natural characteristic of the induction motor. So if we reduce the frequency, we expect the characteristic will move in this direction. صح? NS will be decreased. T maximum will be increased, okay, because it's proportional to 1 over F, okay, and T starting as well will increase. So we expect to have characteristic like that if we decrease the frequency. So in this case here, Shabab, by reducing frequency from 60 to 50 Hertz, we need to compute the motor speed and starting current. Okay, how we can do that? Shabab, how we can calculate the motor speed at the new frequency here?
Yeah, calculating the synchronous speed.
Firstly, synchronous speed can be calculated as 120 multiplied by 50 over number of poles, which is 2 poles here. So this is now the new synchronous speed. So this is now the point here, which is 3000 RPM. The previous one was 36,000, which is here. Okay, and you have constant load torque for instance like that. So this is the first speed, N1. Now we need to calculate N2. So in order to calculate N2, we need what, Shabab? We have synchronous speed. In order to calculate the rotor speed, what is the missed data now?
The slip.
The torque.
Slip, exactly. So we need to calculate S. In order to say 1 minus S multiplied by the value of NS, it will give you the motor speed. So in order to bring or calculate the motor slip, simply we have the torque. Load torque was given is 60 Newton meters. And you know the part here is linear, the part of the characteristic is linear. So we can apply the relation, the linear relation between torque and slip. For that, we can calculate the value of S. We know already the value of V, okay? And omega can be calculated as the new frequency. R2 prime is given, so we can calculate the value of S. As you can see here, the value of slip is 0.0245. Now, since we have S and NS, we can simply calculate the motor speed. Right. How we can calculate the motor current, Shabab? Now we have the value of slip. You have all of the parameters of circuit. However, you only have X equivalent in different value because frequency has been decreased from 60 to 50. So we expect that X equivalent now at 50 Hertz will be 50 over 60 multiplied by X equivalent, which is given in the nameplate data or given in the problem. So simply We can substitute in the equation of current I equal V over Z at S equals unity, because this is now starting current, and the value of X equivalent should be calculated at the new frequency. Yani X was given, I believe it was 5 ohms, or sorry, 4 ohms. So for the 50 hertz, we should multiply by 50 over 60 like that. Yeah, now it's needed to be calculated for both at 60 hertz and 50 hertz. So at 60 hertz, we will substitute at X equal 4, and at 50 hertz, we will substitute at X equals 50 over 60 multiplied by 4. As you can see, the starting current at 60 hertz was 68, and at 80 hertz, at 50 hertz, it's 82 ampere. So starting current increased by reducing the supply frequency. Right. If we applied now V over F control, we said that V over F is efficient technique for speed control. So let's see together what will happen if we apply V over F. What will happen to the values we need. Let's see here the voltage, repeat example 4 for constant V over F. So we need to calculate, as example number 4, we need to calculate I starting and also the motor speed. So these are the targets here, calculating starting current and speed. طبعا starting by the same way يا شباب, we have the value of torque, so we can get slip at which volt? At the volt of 60 hertz. It will be the same like previous example, صح? Which we have already obtained in previous example. This is at 60 hertz. However, at 50 hertz, we need to calculate it at, we calculated at 50 or 60. Previous example was calculated at, here, it's calculated at 60. 60 hertz.
We didn't change the volt in this example. Example number 4, we
voltage was 480 exactly, so we didn't calculate. So we have to start from scratch here. طيب. So for now, if we have V over F constant, let's calculate this constant as 480 over 60. This will be the constant value, which representing the ratio between volt and frequency. It's 8 now. So for V2 over F2, it should be 8 as well. So now V2 over 50 should be 8. So V2 now will be 400. Is it right? If we have now the volt in the second case as 400, and we need to calculate the motor speed at 50 hertz, so we should substitute by voltage equal 400 line to line. So for that, we can substitute now in the relation torque equals 60 Newton meters equals approximately V square, which is 400 now, multiplied by S, required slip, divided by omega, which is 4 by F over number of poles. طبعا شباب here frequency should be considered as 50 hertz, تمام, multiplied by the value of resistance R2 prime. طيب. So as you can see here, this is our slip, our new slip. In order to get the new speed, we can say 1 minus S multiplied by the new synchronous speed. طبعا new synchronous speed at 50 hertz is 3000, so we can say 1 minus 0.035 multiplied by 3000, which is 2894. طبعا comparing this value with the value, actually we don't have the value of 60 hertz here, but I believe we have it before in example 3. Here, the same data, the speed was 3500. Okay, so the speed at 60 hertz rated volt was 3500. Now, after reducing voltage and the frequency, شباب, as you can see, the speed here, the speed is reduced to 2894. Okay, so there is a speed A reduction. طبعا this is expected because we decrease the voltage and frequency according to the characteristic for V over F control If this is a natural characteristic, you will find that the others are moving like that, and so on. وهكذا. Okay, شباب? So we expect for the same torque load constant, if we reduce the frequency, we will have lower values of speed. So the result is logic. Any question?
Yes, Doctor, the torque developed equals the output power over the synchronous speed, right?
Torque developed equals output power over motor speed, not synchronous speed.
Oh, okay.
Sorry, not torque developed, torque output, torque shaft.
Yes. Yeah.
Okay. However, torque developed, which is electrical torque, equals B gap over omega s. Okay.
And this TD is what? The
Torque developed electrical torque. We call it as electrical torque.
Yeah.
But this is the shaft torque.
And when to use this and that?
Shaft torque is used for the output power. So this is the torque at the shaft, and the relation between them, T shaft equals T developed, which is electrical, minus T friction. If rotational or friction losses are neglected, so shaft torque will be the same as developed torque. Right.
And we use omega R or omega S?
Again, it depends on which value of power you are going to use. And you can say T developed equals P gap over omega S, or we can say B mechanical over omega R. It will be the same. Because already B mechanical equals 1 minus S multiplied by B gap. And omega R is the same, 1 minus S multiplied by omega S. So these terms are equal. However, if you have friction in the motor, in this case, T shaft will be P output over omega R, not omega S. Okay? Because the shaft speed depends on the rotor speed, not the synchronous speed.
Yes.
يعني this is not related to the problem, but يعني no problem, we discussed it. طيب. Again, شباب, we calculated the motor speed. Now we need to calculate the starting torque. How we can calculate starting torque? Simply, starting torque means S equals unity. We just will apply the voltage and frequency at the new case, which is 50 Hertz, 400 line-to-line volt. So simply, we can say, again, we calculated the current, the starting current at 60 Hertz, 480 volt, and also 50 Hertz, 400 volt. So simply, شباب, V phase, which is V line over square root of 3, divided by square root of 2 real part square, which is R1 plus R2 prime. طبعا here S equals unity because this is at starting, plus X equivalent square, which is 4 ohms square. This is at rated voltage and frequency. However, at small or reduced voltage and frequency, the volt is 400, frequency is 50 Hertz, so we have to multiply the reactance by 50 over 60. So as you can see here, this is our starting current, and here as well, it's the same. So this means V over F control will not affect the starting current. It will be the same. Okay? تمام يا شباب? Is it clear? Now we finished all of the speed control techniques in terms of problems. يعني we will not have any problems regarding speed control.
Doctor,
slip energy recovery. تفضل.
can you go back to the last slide?
تفضل.
So every time we get a ratio, like a different ratio, we need to like multiply about that ratio, like 50 over 60 and so on.
It should be equal all of time. If I make constant flux control or V over F control, all of times V over F should be constant. So if you change the frequency, you have to change the volt in order to respect the same ratio.
Oh, okay.
Okay. Last technique يا شباب is slip energy recovery. We discussed previously the adding resistance to rotor circuit. So in a slip ring induction motor, we can add resistances on the rotor side in order to control the motor speed. However, we said that the power loss in the resistance will be high, and this reduces the system efficiency. So instead of making that, we will return this energy to supply again. And by controlling the valves here, which is the power electronic converters, we can control the motor speed. In order to understand that, let's return back to the added resistance again. Just to see together this slide. Here يا شباب, in this technique, either open loop or closed loop, we said that we will rectify the AC power from rotor to DC, okay? And by means of controlling the AC to DC and the DC chopper here, we can control the effective value of resistance. So the effect of controlling power electronic converters will be reflected on the impedance or resistance seen from the rotor side. Right. Similarly, for our technique here, which is slip energy recovery, according to the control that we are going to make here at the inverter, this is called inverter, we will convert from DC to AC, and this is called rectifier. It's converting AC to DC. So according to the firing angle of the pulses which are going to the thyristors here in the inverter, based on this value, we can control also the value of resistance seen from this side. And as well, it will control the motor speed. So it's similar to adding resistance. However, instead of adding a resistance in this side, we can now return this energy to supply. So here we have the benefit of removing the copper loss on external resistance. Yani instead of making external resistance loss, we return this energy again to the supply. So this is the idea of slip energy recovery. Okay, so we call it as slip energy because we captured the energy from the slip rings and rectified and inverted this A power and returned this power again to the supply. How we can control the speed now? By changing the value of alpha. The relation is S0, which is slip at synchronous speed here, which is representing the value of ns. S0 equals minus V1 over E2 cosine alpha, where V1 and E2 will represent the voltages here in the circuit. V1 is considered as the voltage here. E2 is represented by the EMF, which is attained here, like Vn, this one, okay, multiplied by cosine alpha. So based on the cosine alpha now, based on the angle alpha, we can control the characteristic like that. And if we have, for instance, a constant load torque, so as you can see, we have wide range of speed control, okay, similar to the added resistance. However, the only difference between the added resistance and this technique that ns is not constant. Here, as you can see, ns is moving, okay, or changing because we control the voltage here and frequency as well. Why frequency? Because you know the frequency of the rotor circuit is small, and we need to connect this power to the main supply of the stator. And in numbers, for instance, if we have F1 of the stator as 60 Hertz, if the slip at certain point is, for instance, 0.02, so we expect to have around 1.2 Hertz. صح يا شباب? If you multiply 0.02 by 60, what will be the frequency? 1.2 hertz, صح? So the frequency here is 1.2 hertz. However, we need to convert this to DC and then to AC again with the same frequency, which is 60 hertz. For that, you will find due to this control here, the value of NS has been changed. Fine. So the advantage now of slip energy recovery is that we return the energy again to the supply. So what will be the power flow in this case? This is the input power to the motor. We will say that we have source power plus returned power. And finally, the efficiency will be B out over B source, not over B input. So as you can see now, we have B input. It's divided to copper and core losses and B gap, then B gap to copper and mechanical power. Copper power will be divided in two parts: copper loss on windings and the power returned again to the supply. So for now, شباب, the efficiency of the motor will be P out over P source. Okay, شباب. If you compare this to previous efficiency, which was P out over Pn, you will find that due to B source is lower than Bn, you will find that efficiency at slip energy recovery is higher. صح يا شباب؟ يعني in numbers now, what do you expect? B source or B input? Which one is higher?
B input is higher.
B input is higher. صح يا شباب؟ So if B input is higher, this means this relation efficiency is lower than the previous one here, which is slip energy recovery. تمام? For that, this technique can increase the system efficiency. So this is now the advantages of slip energy recovery compared to adding resistance technique. Sometimes this technique, شباب, is called static Kramer method. Okay. Regarding starting of three-phase induction motor. يعني this part, شباب, I will leave it for you to read. I will just make some comments on starting because يعني I know يعني most of this have been discussed in previous course EE360. The problem of starting, شباب, is mainly the starting current of the machine is from 5 to 7 times. The problem is not on the motor itself because transient time is very small, and the motor after few seconds will reduce the current due to the يعني absence of transient. يعني in the starting, يا شباب, if we can say the RMS value of current, if I representing here I root mean square with time, you may find that the current at starting is high, and after certain cycles it will be like that or even lower. So here, let me redraw again, please. Sorry. Again, شباب, يعني if this is the value of current at starting after يعني few cycles according to the machine time constant, the current will be reduced like that. So if this is now the value of I full load, this value is expected to be from 5 to 7 of I full load. Okay. Type. So this is the shape of RMS current, not instantaneous. The time up till here, شباب, we call it as transient. So this period representing the transient time, and the period starting from this instant is called the steady state. All of time in our calculations we consider steady state. In all of our problems we consider only steady state operation. However, we did not consider the transient. طيب, what is the problem now of starting? يعني as we said now, the motor itself will be يعني converted to steady state. It will take few periods or few cycles as transient, and it will be converted to steady state and the current will be reduced. So what is the problem? The problem is not with the motor itself. The problem is the surrounding loads, because 5 to 7 times of the current at starting will make a suddenly voltage drop to the supply. And if you have any critical load with under voltage protection, this device may be disconnected because of the voltage drop. You can recognize that at home. If you turn it on the vacuum cleaner, you will see the lights dropping for a very few seconds, or maybe less than seconds, okay, and return it back again. This is only at starting of the vacuum cleaner. Why? Because this is induction motor and it's absorbing high current at starting. Right? If we have critical load, again, it will be disconnected. So what is the solution? The solution is to reduce the current at starting in order to prevent other loadings from disconnecting at starting of machine. Right? How we can do that, Shabab? Simply in the as we discussed in our classes, we can add resistances at starting. However, adding resistance itself as a technique is not preferred. So instead of adding resistance, we can start using power electronic converters and changing the value of volt, for instance. So we can increase the supply frequency or reducing the starting voltage. Increasing supply frequency as well will reduce the current. As we could see in the solved problems, Shabab, if we increase the supply frequency, the current will be decreased. However, increasing supply frequency, and if we return it back to the supply frequency here, this is the voltage control, frequency control, okay? So increasing the supply frequency, as you can see, what happened to the torque? It's decreased. So if you have constant load torque, it may make a problem. So this is the drawback of frequency or starting with high frequency. Type. So we have now either adding resistance, increasing supply frequency, or reducing starting voltage. But you have to consider your case of loading. If it is constant load torque, you have to consider that and keeping T starting greater than the load torque in order to start your load. Adding resistance, we know adding resistance techniques and we discuss it. Okay, we're discussing adding resistance. As you can see, you can increase the value of T starting, okay, and at the same time it will reduce the value of starting current. So as advantages in terms of starting, it's increasing the starting torque, so it's suitable for constant load torque, Shabab, and at the same time maximum torque can be obtained at starting, so you can start with constant load torque easily. However, drawbacks, it's limited only to wound rotor. It cannot be used for squirrel cage induction motor. طبعا يا شباب, regarding this part, you know that, or we discussed it before, at this point, شباب, if we made T starting equals T maximum, S maximum will be unity, because you know at this end point S is unity all of time. Okay, so at this curve, maximum torque is the same as starting torque. So you can say SM, which is slip at maximum torque, equals unity. And in this case, you can get the value of added resistance. Right? And we discussed it, and we had a problem in our lab in the previous exam regarding this part, and unfortunately, most of you did not solve this problem. So please, just study this part well. Time. Again, regarding currents, how we can reduce the current, Shabab? We said by voltage or frequency. Let's see together how we can reduce by voltage. We have conventional techniques and we have advanced techniques. Firstly, we can start by reduce the voltage using conventional techniques like using auto transformer. You know, auto transformer, you have a winding like that. This is the overall winding of the transformer. In the starting, you can start by a part of the voltage. So if you apply S as short circuit and R as open circuit now, this means that S is starting running, S is a coil or contactor which is working at starting, and R is a contactor working at running, which is at steady state. So if you close S now like that, you will take a part of the voltage. However, at run operation, you should turn off this contactor and turn on that contactor in order to take all of the voltage. Right. So this is regarding auto transformer. Auto transformer can start the induction motor with small voltage. However, it's only manual control. It's not automated technique. Or you can make it controlled by using timers along with contactors. You will use lots of devices in this case. It's not preferred anymore. Another technique is star delta switch. Star delta switch can be made also manually or using classical control by using the contactors and timers as well. Tamam? Star delta switch, the main idea is to start the machine where connecting the motor as a star. If you connected the motor as a star in this case, the phase voltage will be V line over square root of 3, which is 58% of rated voltage or line voltage. So you start already the machine at lower voltage. Then if you convert the connection from Y to delta, it will be connected again to supply the motor with the line to line voltage. So this is another technique to supply the motor with reduced voltage. The modern techniques are depending on power electronic converters, so we use the back-to-back converters or AC chopper in order to supply the motor with reduced voltage. How we can control? Here we can control by changing the value of firing angle. We discussed previously the use of AC chopper, okay? And here by using something called pulse width modulation. We will discuss it at the last topic in our course. Pulse width modulation can control the 6-switch inverter in order to control the output voltage here. طبعا it can control V over F, however, V and F. However, here at starting, as you like, if you would like to control frequency as well, you can, in order to keep the torque starting high. However, if you made V over F at starting current will not be affected. Okay, so we prefer to make starting using V only, and after that, controlling the machine by V over F. So this is Shabab regarding the starting. Now, this part is new for you, which is braking of induction machine. Braking of induction machine. What is the meaning of braking? Braking is a generic term used to describe a set of operating conditions for electric drives. It includes rapid stopping. We need to stop a motor very fast. Holding the rotor shaft at specific position. For instance, the elevator. We need to move the elevator and stop the elevator at certain position. So this is a kind of controlling or braking also. Like printer, Shabab, controlling the printer, you need to apply a torque on the motor which is driving your printer and hold it for a certain period in order to block the line and then move the motor again. So we can use here braking and holding. Also maintaining a motor speed at desired value. So in speed control as well, we make a part of braking. In speed control, we make a part of braking. Okay, and we will discuss it in curves how we can do that. Preventing the motor from overspeeds, which is a limitation for the speed to avoid overspeeding of the machine. All these aspects, Shabab, of braking are done electrically without mechanical brake. For your car, all or most of our cars now, we have our conventional cars based on heat engine, and the braking is made using mechanical brake, not electrical one. However, we need to make electrical brake by using motors. During the braking, يا شباب, mechanical load is considered as a source of energy. This is very important. During the braking, I will take the energy from the load and will use it. This is what we are going to say as regenerative braking, and we will discuss it. The accurate and fast braking method is preferred. If you need to stop your car, for instance, you need to stop it very fast to avoid any accident, for instance. So if your braking technique is accurate and fast, this will be very good. An example for braking, يا شباب, is like robot. A robot in a line must be able to stop the line, to hold the line at a certain position, or to reverse the motion. Okay, how we can do all of these? This can be done by using braking. Hi. There are three different types of braking we are going to discuss, يا شباب. First is called regenerative braking. The second is called dynamic braking. The third one is called counter-current braking. So let's start discussing the meaning of each type. Firstly, regenerative. Regenerative braking, it means an electric motor is in regenerative braking when the load torque reverses its direction. Again, يا شباب, regenerative, it's similar to generator operation. If we have a motor which is working in a certain quadrant for voltage and for torque and speed, let me draw here in this here the characteristic of the machine, but now we will draw the machine characteristics typical to drive systems we use. So torque will be in the horizontal axis and speed will be in the vertical axis. So for induction motor characteristic, the characteristic will be like that. Okay, this is the machine characteristic. This is here representing the motor, يا شباب, motoring mode. And here the operation will represent generating mode. So if the torque is reversed and be negative, and speed will be positive in the same direction, the machine will be converted as generator. This is what's called regenerative braking. So the machine is working as motor, however, as a part or due to a part of control, we will return the energy to supply and the torque will be negative. So this is representing the regenerative braking. So in order to do that, we need our load to be flexible enough to be reversed to negative. Not all of loads can be converted to negative, only active load. We call it active or reversible loads, يا شباب. Okay, these loads can be converted to negative. So for active or reversible loads, we can return the energy to supply and causes the machine to run at a speed higher than no load speed. No load speed, or we call it all of time, شباب, no load speed or synchronous speed, which is this point. So the speed will be higher than no load speed. The torque will be reversed, so it's now working as generating mode, يا شباب. Okay, so this is now considering as the regenerative braking. For instance, a trolley bus, this example, يا شباب. If we have a trolley bus like that, in the uphill direction is working in the motoring mode. Now, as you can see, we have motors here. These motors will make force to move the trolley bus in that direction. So this is the direction of electrical power, of electrical force. the load direction of the bus will be reflected on the way in that direction. So this representing now load. This is load force and this is motor force. Okay. This is in the direction moving uphill like that. So this is now motoring mode. If you start going downhill, what will happen? Now the torque direction will be reversed. So the torque direction now of the load will move the load in that direction. So it's reversed. And in this case, you have to use your motor to brake the motion. So the motor force has to be in the opposite direction. And in this case, the energy will be returned to the supply because the torque has been reversed. Okay, so this is called now regenerative braking. Is it clear, شباب?
That means it will operate in the reverse direction of the torque. Am I right?
Exactly, the torque will be reversed, not the speed, only torque. As you can see here, speed is the same. Sorry, not the same in value, but the same in direction. Okay, and the value of speed will be from, for instance, moving from here to here. Okay, from that point number 1 to point number 2. تمام? In this case, the machine will work in the regenerative braking mode. Only.
Here, the machine itself is the braking.
The machine itself will serve as a brake. The motor itself. Okay.
Okay.
So, Doctor, this is done by we reverse the flux or what?
How we can make it? I will discuss it with you now. You will know exactly how we can make this a torque reverse. Actually, it's basically it depends on the load as we discussed. Okay, so in terms of circuit, I will discuss with you on the characteristic here. You will see it now. Right. So now, شباب, in terms of as we could see in the quadrants, we have the first quadrant. This is called first quadrant. In the first quadrant, which is the motoring mode, we have a load. If we assume that this is a speed direction, which is positive, so the torque of the motor will be in the same direction with the speed, which is representing the motoring mode, and the load torque will be opposite. All of time, torque load is opposite to the motor torque direction. However, when we will work in regenerative braking mode, you will find that torque load is reversed and the motor torque is reversed as well. Why? In order to operate the machine in the regenerative braking. However, the speed will be in the positive direction as it is. So, in terms of relation, how we can transfer the characteristics of the machine during this part and take care that this is not happening for all of time. This can be only as a part of time. Okay, it can be made for long time if it is reversible load. However, if the load is unidirectional, not active, we can also have a part of regenerative braking in speed control only. How? Let's see together. Here in this example, for instance, we have active load torque, which means the load torque itself can be reversed, can be positive or negative, like the example of the trolley bus. So in this example here, in T1, this is the operating mode as a motor, and at T2, the motor, the machine operated now as regenerative braking or generator here. تمام? So what will be the relation now? طبعا the developed torque is the same, no change in the relation of developed torque. However, the slip, which is ns minus n over ns, will be positive or negative, شباب here? at point number 2 يعني N2 is greater than NS صح؟ So if we represent S2, this means that S2 will be negative because NS is less than the value of N. So in regenerative braking, you will find S in negative. طبعا here S square will be a positive because it's squared. So this sign will be negative. For that, the torque developed will be negative. Okay. So this is for the regenerative braking. If we have,
Doctor.
تفضل.
So if exceeded the synchronous speed, is it that like okay, like does it affect something, the whole process?
There is no any effect for synchronous speed. Yani we did not change anything.
No, I mean like because it became negative since that our speed exceeded it. So is that like a normal thing?
Yes, it's normal. This is the conversion from motoring mode to generating mode. And we discussed the modes of operation before. The example is like the motor is going downhill. Now, if you with your car, even with your car now, if you left the car without brake, what will happen to the speed?
Depends on the medium or like that you are driving on. If it's
okay.
like in
like downhill, like
oh yeah, the speed will increase.
It will increase. This is the idea now. If the speed start increasing, your role now is to reduce the speed by making braking. صح? This is for conventional cars. The same is also here. And now there is a speed, and the speed is high depending on the road. Okay, and in this case, it will move to a value higher than the synchronous speed. So we can use this advantage in order to control the machine to be working in the regenerative braking. How we can do that in the motor? Now we have variable speed drive. So if you control your variable speed drive to have NS lower than N, whatever the value of N, you will control the NS to be lower. How you can control NS? By means of frequency, for instance. Okay? So if you reduce the frequency to reduce NS, in this case, you will be converted in the regenerative mode. And you will return the energy to supply. طبعا the aim of the operation is to brake the motor or reduce the speed. صح? This is the idea of braking. However, the benefit is that we return the energy gained from the operation to supply. So how we can do? By controlling frequency and NS. This is for reversed or reversible loads يا شباب. In speed control, let's discuss together one of the techniques for speed control at using V over F for instance شباب. Okay, at certain operating condition, for instance, you have or you would like to control the speed to move from point 1 to point 3. So we will control the characteristic of the machine to moving from this curve to that curve at F3 and V3. Can the machine moving from a characteristic to another one at zero speed or at it change the value at zero time without any change in the speed, or the speed has to be changed gradually? طبعا speed has to be changed gradually. صح ولا غلط شباب؟ How it can be made like that? First, at the same speed, you will start moving to another curve. So by applying certain voltage and frequency, you will create that curve, and instantaneously the machine will move from curve number 1 to curve number 2 at point 2. At this instant يا شباب, is the machine working as motor or generator?
Generator.
Generator.
It's generator now, because torque is negative. And then we need to control the speed to be at the same value here at point number 3. So the machine will travel on the same curve up till reaching point number 3. So even in speed control, there is a part of the operation or transient in the transient operation or dynamics of the machine movement from 2 points. The machine will operate at the regenerative mode. Okay, so even for speed control, you need a part of regenerative braking. So these are the two cases that we can find regarding regenerative braking. Either if we have an active load, and this can be controlled to be operated at regenerative braking for a long time, or if we make speed control, we can also have a part of regenerative braking during the movement from one curve to another. يعني the time now is يعني the class time. So inshallah next class we can continue discussing يعني some parts regarding regenerative braking. Any question شباب؟ Any question؟ اوكي شباب نشوفكم الكلاس القادم ان شاء الله على خير. السلام عليكم ورحمة الله.
Doctor, if you can upload the harmonics